Hi everyone, welcome to this channel. In this video, I'm going to discuss the topic function and graph. So given the function fx is equals to exponent 2x plus 1, followed by the gx is equals to 1 over 2 ln bracket x minus 1. Show that the function fx is one-to-one function algebraically. So first, what we have is f x sub 1 equals to f x sub 2. Next, substitute the situation. So where we have exponent 2 x sub 1 plus with the 1 equals to exponent 2 x sub 2 plus 1. Simplify the situation. Exponent 2x sub 1 equals to exponent 2x sub 2. Compare the situation and we will have 2x sub 1 equals to 2x sub 2. Simplify. Finally, we will have x sub 1 equals to x sub 2. So it implies that, show that function of fx is one-to-one function. Because x sub 1 equals to x sub 2. B. Find the f rho gx and also the g rho fx. Hence, state the relationship between the fx and the gx. So now we are going to discuss the composite function. F rho g equals to f rho gx. Substitute the function gx into the fx. So where we will have exponent 2 multiply with 1 over 2 ln bracket x minus 1 plus with the 1. Simplify the situation where we have exponent ln bracket x minus 1 plus with the 1. So by using the properties of indices, exponent ln, we will obtain 1. So where we will have x minus 1 plus with the 1. So finally, f rho g for the function, we will have x. Next, we are going to find the g rho f. So g rho f x is equals to g for the function fx. So meaning that substitute the fx into the gx. So where we will have 1 over 2 ln bracket, substitute the fx as a x. Exponent 2x plus 1 minus with the 1 bracket. Simplify the situation, 1 over 2 ln bracket exponent 2x. So by using the properties, as we all know, ln exponent, we will have 1. So finally, we will have 1 over 2 multiplied with 2x. Then, the g rho f is equals to x. Hence, state the relationship. So, from here, we notice that the f rho g is equals to x and the g rho f also equals to x. So, in this case, gx and the function fx are inverse to each other. So meaning that the gx is equals to f inverse of x, or the fx is equals to the g inverse of x. So that is their relationship between the fx and the gf. Since the b, the relationship between the fx and gx are inverse to each other. So meaning that c, sketch the graph of fx and gx on the same coordinate axis. So now we have the xy axis on the right. So kindly focus on the fx. So for the fx is equals to exponent 2x plus 1. So the first part is we are going to sketch the graph exponent 2x. So basically we have the graph. So for the exponent 2x, the graph would be where we have y equals to exponent 2x. And the asymptote is y equals to 0. Next, if the situation is exponent plus exponent, if the situation is exponent 2x plus 1, so meaning that the graph need to be shift upward for 1 unit. So now the asymptote will become y equals to 1, and the graph will be looking like this. So where we have the intersection point become 2. So now we need to sketch the graph for the right hand side, where we have the asymptote y equals to 1. Then for the exponential function, the graph would be denoted in green in color. So where we have the intersection point 0, 2. So the function would be fx equals to exponent 2x plus 1. Next, we are going to sketch the gx by using the reflection. As we all know, y equals to 1. If you reflect, it will become x equals to 1. Where we have x equals to 1 for the asymptote. Next, what we have to do is to reflect the point. In here, we have 0, 2. So, if we reflect, the situation become 2, 0. As the graph for the ln, the x is positive, so the graph will towards the right. So the graph for ln x minus 1 will be like this. Then we have the reflection axis, where we have y is equals to x. And the function for the blue in color will be gx, or the f inverse, where we have 1 over 2 ln x minus 1. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.